All right, so today we'll finish up law of sines. Okay, so the last thing we have to look at is the side-side angle case. And we're going to look specifically at what happens when you get the two solution and the no solution. And then after that, we'll finish up with a couple word problems. Okay, so for anybody that wasn't here yesterday, that's the law of sines. Okay, if you were here, you already have that in your notes. And really, there's no new ideas I need to explain. We're just going to use that formula and solve problems exactly like we did yesterday. The idea here is you only use two parts of this law at a time. Either the first two parts, the last two parts, or the first fraction and the last fraction. All right, so let's solve this and see what happens. Okay, so I'm going to make a sketch so I can see what type of problem it is. But by looking at the table, can anybody tell me how I know it's going to be law of sines? Alex?
You have one row filled in.
Right, I have one row that's filled in, so that tells me it's law of sines. I have one row that's completely empty. That tells me it's the worst case, where I have to deal with the one solution, two solution, no solution. All right, let's make a sketch. Okay, and again, the sketch here is not to scale. So there's A, alpha. I'm going to put B across from beta, C across from gamma. Now if I look at the three pieces of information that I have, side, side, angle. Okay, so this is side, side, angle. And it's important that we notice the angle they give me is not the one that is where the two sides meet. It's not the angle that's between the two sides. Okay, that would be gamma. If that was the case, it would be side, angle, side, and that's a problem we don't know how to do yet. Okay, that'll be tomorrow. Okay, so any questions on why it's side, side, angle? Okay, if you look back at your notes from yesterday, that is one of the three types that fall under law of sines. Okay, the other ones are angle, side, angle, and angle, angle, side. All right, so because it's side, side, angle, you have to solve it in a certain order. Haley, do you remember what I said you have to find first here? Yeah, you've got to get beta first. Okay, you don't have C and you don't have gamma, so you can't do anything in that last row. Okay, so we got to forget about it for now. Okay, so let's see if we can find beta. Okay, Eric, do you think you could set up my proportion for me that would solve for beta?
We do sine 35.
Okay.
Over 6.
Yep.
Then sine of beta.
Yep,
Over 8.
Over 8. Okay, so we'll cross multiply. We're going to get 8 sine 35 equals 6 sine beta, but I'm going to move the 6 to the other side by dividing. Okay, so now I've got sine beta by itself, but I want to get rid of sine. So Paige, how do we get rid of sine? Yep, I'm going to take the inverse sine on the right. That's going to cancel regular sine. And we also have to do it on the left. Okay, now at this point we want to type it in and see what we get for an answer. But I'm not going to type in the sine of 35 and then round it off. I'm just going to type the whole thing in at once and round it off. Okay. Because every time you round, the answer gets less and less accurate. So just try to type the entire thing in one step. Okay, I think my calculator is already set, but Molly, what do we want to make sure of about the mode for this week on our calculator? we always want to make sure we're in degrees. Okay? It's not that you can't do law of sine problems in radians. You definitely can. We're just doing them in degrees. Okay, so inverse sine of 8 sine 35. Make sure you close the parenthesis. Divide by 6. And I get 49.886. So this is not a no solution. This definitely has a solution. So let's write that down. All right, so we got that. Connor, do you remember what I do with that number to find the second solution?
You subtract the beta by 180.
Okay, so we're going to take beta and subtract it from 180. All right, so 49.886. And I get 130.114. Now, we don't want to write it down yet. We've got to check if it works. So Robin, do you remember how I check if that answer works? Well, what has to happen with all the angles in a triangle?
They have to add up to 180.
They have to add up to exactly 180. So what angle were we given here?
Yeah, alpha.
Which was how much?
35.
35. So would it be possible to fit the angle we just found, 130, and a 35-degree angle in the same triangle? Yeah, because that would only add up to 165. So this time, the second answer is small enough that it does work. So now we need to write that one down. So is there any question on how I found the second answer or why it works this time? All right, so what I'm going to do is call that beta 1. And I'm going to do the one below it, 130.114, that'll be beta 2. So Alex, if I've got 2 answers for beta, what else am I going to have 2 answers for?
C and gamma.
Yep. You're not going to have 2 answers for the stuff that was given. Okay, that stuff that was given, we don't have to do anything with it. It's just the stuff that you have to find. All right, so really what we're doing now is we're solving 2 problems at the same time. Okay, so if you want to look at it, one triangle you're solving has alpha, beta 1, and gamma 1. Okay, we'll call that the green triangle. The other triangle we're solving has alpha, that's in both, beta 2, and gamma 2. That's the blue triangle. So we have to make each triangle, the green one and the blue one, add up to 180. Right, so let's see if we can find gamma 1. Emily, what 2 angles would I add together to find gamma 1 and then subtract from 180?
35 and 49.886.
Yeah, we're going to add the 35 and the 49.886. 0.886. And then we're going to subtract that from 180. Okay, so gamma 1 is 95.114. And now for the blue triangle, that's alpha, beta 2, and gamma 2. All right, so let's add those up and then subtract from 180. So alpha and beta 2 is 165.114. So 165 and subtract from 180. And gamma 2 is 14.886. Any question on how we found gamma 1 or gamma 2? All right, so the last thing we have to find is C1 and C2. And what row do you think I should use to find both C1 and C2? Got to use a row with everything in it. Yep. Yeah, I should go back to what was given because Row A is a row that you can use in both triangles. A is in the blue triangle, B is in the blue triangle, and C2 is in the blue triangle. And then if you want to look at the green, A is in the green triangle, B is in the green triangle, and C1 is the green triangle. Okay. So notice that first row it's in both. Okay. So any questions on why we're going to use row A? All right. So let's set it up. We're going to use row A. And what else am I going to use to find C1? Would I use gamma 1 or gamma 2? Anyone think they know? Ashley? Yeah. If you want to find C1, you use gamma 1. If you want to find C2, you're going to use gamma 2. All right. You know what? I'll just do it down here. Find C1. Find C2. All right, so we said we're going to use row A, so let's fill that in both. Sine 35 over 6. Over 6. Sine 35 over 6. Now for C1, use gamma 1. Sine 95.114. And to find C2, use gamma 2, 14.886. And now we solve each one of those separate. All right, so C1. Connor, can you tell me what, you don't have to give me the decimal, but just tell me C1 would be what times what divided by what?
You have to cross multiply.
Yeah, so after you cross multiply and then get C1 by itself.
What was the question?
So I just want to know what would C1 equal when you get it by itself?
6 sine 95.112.
Yep, divided by,
Sine 35.
divided by sine 35. Okay, so type that in, and that'll be the answer for C1. And then Irene, can you tell me the same idea? Give me my fraction for C2.
C2 equals 6 sine 14.886 divided by sine 35.
Divided by sine 35. And there's your answer for C2. Does anybody have what either one of those come out to as a decimal? Either C1 or C2? Yeah, Emily?
C1 I got 10.419.
10.419.
Yeah.
All right. And did you also get C2?
Yeah, I got 2.687.
2.667.
87, sorry.
2.687. Okay. Did anybody else get those? Yep. All right. So now for each triangle, the green, I called them the green and the blue. We should just check, make sure the biggest side is with the biggest angle and so on. So for the blue, beta 2 is the biggest angle, and out of all the boxes in blue, B is the biggest side. For green, gamma 1 is the biggest angle. C1, out of all the boxes in green, is the biggest side. Okay, so everything looks reasonable. How do you get gamma 1 and gamma 2? So what you've done is you were given alpha. You find beta 1 and beta 2 first, and then you take alpha plus beta 1, subtract it from 180. That's gamma 1. And then take alpha plus beta 2, subtract it from 180. That's gamma 2. Okay, so the order you have to do this problem in is find your betas, find the gammas, then find the c's. There's no other order you could go in. Okay, so any questions on that one? All right, so that's a problem where basically it's like if you think about it in terms of like building something. Let's say I gave you, a stick that was 6 inches long, another stick that was 8 inches long, and I said that I want the angle across from the stick that's 6 inches long to be a 35 degree. Okay, so you take your protractor. Now, if people were to work on that, there would be 2 different triangles people could create. Some people might make the other stick 10.4 inches. Some people might make it 2.7 inches. You'd each create 2 possible answers. So we're going to look at how that can happen visually. Okay? So I'm going to show you how I can take this triangle. I'm going to copy 2 of the sides and 1 of the angles and make a totally different triangle. Okay? But I'll keep 2 sides and 1 angle the same. All right. First thing I'm going to do is just take that side and copy it. Okay. So does everyone agree that that side and that side are the same? Okay. So there's one side that's the same. I'm going to take this side, I'm going to copy it, but I'm going to flip it or reflect it. Now, does reflecting it change the length? No, it's like a mirror image of it, but it's still the same length. All right, so let's move that right there. So now I have 2 sides the same. And then what I'm going to do is just connect the bottom to make a horizontal, about like that. And if you look at that, you might be like, well, wait, where's the angle that's the same? But if you move it up, you can see it's the angle in that corner. It's exactly the same angle. So that angle matches that angle. So you have side, side, angle. And visually, that's how you can get the 2 solution case. And that's also why in geometry, you never use side-side angle to prove something congruent. You can't. Because side-side angle, there are 2 possibilities, not just 1. Okay? When you're trying to prove something congruent, you have to have just 1 possibility. You have to prove that something is exactly like something else. But side-side angle doesn't do that. There's 2 options. So any questions on the 2 solution case? Okay, that's about as bad as it gets. Okay, even with the stuff we do tomorrow, I think that's probably the worst because you have 6 things you need to solve for. No other problem this week will have that. Okay, let's look at this one. So I know it's a law of science problem. I got a row with everything in it. I also have a row with nothing in it. Okay, that means it's side-side angle. So Zach, what do I have to find first here? Alpha. Yeah, I've got to find alpha. You can't do B and you can't do beta because that row is totally empty. So if you pick the second row, you're going to have 2 things that you don't know. Okay, so any questions on why we've got to do alpha? Okay, let's set it up and watch what happens. So you have sine of 50 over 1. So actually, you don't even need to put it over 1. Equals sine alpha over 2. Okay, all you need to do really in this problem is multiply each side by 2. You don't even need to cross multiply. So you get 2 sine 50 equals sine alpha. And Hayden, how do we get rid of the sine function? careful, it's a function. You can't add, subtract, multiply, or divide to get rid of a function. Like if I said to you, you've got a square root, think about how you would get rid of like a square root function. Yeah, it has the negative. Does anyone remember? Yep, Rudy? That's the inverse sign. Yep. So if you want to get rid of a function, you've got to use another function. So inverse sign. Okay, inverse sign. And let's type it in. So inverse sine of 2 sine 50. Second, inverse sine, 2 sine 50. And I got an error. Did anyone else get an error that tried to type it in? Yeah. And what's happening here is, forget the inverse sine for a second. Just look at 2 sine 50. 2 sine 50. The value of that is 1.53. Now, last week we studied the sine function. How high and low does the sine function go if you don't do anything to it? You remember, Rudy? Yeah, the lowest is -1, and the highest is +1. So let me put 1.53, that's what we just got, and let me graph sine. And by trying to take the inverse sine, you're basically asking, where do these two graphs cross? Where do they cross? They don't. That's why you get an error. It's impossible. Okay? So I'm just trying to show you visually why you don't get an answer, and I just showed you on the calculator you get an error. Okay? So there is no solution for alpha. Well, if there's no solution for alpha, what else does that mean? You can't find a solution for beta because you would normally add alpha and gamma together now and subtract from 180, but you can't. And if you can't find beta, what else can't you find?
B.
You can't find the side that's across from it. So this is a problem that's impossible. Okay? You could not make a triangle. If I gave you like a piece of wood 2 feet long, another piece 1 foot long, and I said I have to make the angle across from the side that's 1 foot long 50 degrees, you can't do it. Okay, so I'm going to try to draw it and we'll see what happens. All right, so what I'm going to do first is I'm going to call that 1 unit. Then it doesn't matter what it is, 1 inch, 1 foot. And then I'm going to make one 2 units. And I'll just try to group them together. Right, so now I got something that's 1 unit long, something that's 2 units long. So A is 2 units long, and I used a protractor earlier to measure a 50-degree angle. That's exactly a 50-degree angle. So I'm going to turn this so that it's at a 50-degree angle. And that's actually pretty good. Okay, so now I can't adjust that. I can't turn it. Because if I turn it, it's not at a 50-degree angle to the horizontal. All right, now C is 1 unit long. C is the side that is going to come off of A. Right? Now, that I can turn any way I want. But in order to turn it, to get the little green circle that lets me turn it, it's kind of weird. I have to group it with something. And then I can erase what I grouped it with. And now I have the little green circle. So I can turn that any way I want. So there's C. And now B wasn't given. So you can make B as long or as short as you want. You can do whatever you want. The only thing you have to do is keep B horizontal. Because if you start to turn B, you're going to mess up the 50-degree angle. Okay, so make B any length you want. Is C ever going to connect to side B? No. No matter how you turn it, Okay, and you can make that shorter, but it's never going to connect. Okay, that's why it's no solution. Okay. A little bit harder problem would be to say figure out the minimum length C could be so that it does connect. Right now C is too short. What if C was 1.5? Would it connect then? Okay, what would be the smallest number that C could be, and it would just barely connect? That would be a really challenging bonus kind of problem. Okay, any questions on that one? Okay, so that's the two solution case, which takes a little longer than normal, and the no solution case, which is pretty fast. All right. All right, so let's look at two-word problems, and then that'll be it. Keep in mind, generally, when you're doing a word problem about like distances between objects or angles, there is only one answer. Okay? In real life, if you were measuring the distance between two objects, you only get one answer. So you're not going to have to deal with a two-solution case when you do a word problem. All right, so this problem says to measure the height of a mountain, a surveyor is going to take two readings, two sightings of the peak. So what the surveyor is going to do is they have probably what's called a transit. They're going to set up their transit, which is on like a tripod. They're going to look through the scope or whatever's on it. They're going to point a laser exactly at the peak of the mountain. Right. And the surveyor is going to do this twice. So the surveyor is going to do it at one spot, shoot a laser to the top of the mountain, and then they're going to drive 900 feet back, or 900 meters back, and then do the same thing again. Now, as you move away from a mountain, the angle to it changes. Okay, think about like if you're at the movies. If you're really, really close to the screen, your angle to the screen is really steep. As you move further and further away from the object, the angle to the screen is not as steep. Okay, same idea. So as the surveyor backs up, the angle gets less steep. So the first time the surveyor does it, they get an angle to the top of the mountain of 47 degrees. Okay, so now the surveyor gets in their truck, they drive backwards 900 meters, do the same thing again, and they get an angle of 35 degrees. Okay, so I'm really kind of writing out the whole story here, but I mean, you could just shorten it, like first angle, 47, second angle, 35, if you want to shorten it up. Now, not that it's hard to take into account the height of the transit, that's the object that the surveyor is using to measure, but we're going to assume that the transit is ground level. Okay. If you really wanted to do this accurately, what you would do is, when you're done the problem, you would add the height of the transit in. So if the transit was 5 feet off the ground, you would just do +5 to your answer. But we're not going to worry about that. All right, so we got a lot of information here. What do you think would be helpful to do with all this information so we can kind of see it better? Okay, you can make a table. For this one, I don't think I'm going to do the table. Yeah, let's make a picture of the whole thing. Okay. So, when I start to make a picture, what's something that's very important that needs to be in my picture? Like some basic things that have to be in it. About that?
I need the values of the angles and the distance that it is from the mountain.
Okay, so we're going to write in values, but for now, let's just think objects. What objects need to be in my picture?
The mountain.
The mountain, and the mountain is sitting on the
Ground.
ground. So let's start with those two things. Ground. Okay. Mountain. Okay. And the surveyor is going to take two sightings. One here, one here. And we know that the distance those sightings are apart is how far? 900 meters. So this is 900. So we're going to get a sighting to the top of the mountain there, and another one from there. Okay, I'll put those in as dotted lines. So it represents, it's just an imaginary angle to the top of the mountain. Close that one, and that one. Okay, so the first time the surveyor does it, they get an angle of 47 degrees. That's right there. So 47 degrees is the angle with the horizon. So if you were trying to, like, if there was a target on top of the mountain, you would have to angle whatever you're shooting up at 47 degrees to hit that target. All right, and then the second time, the surveyor gets an angle of 35. All right, so what we really want to find is this. That's the height of the mountain. And I'll put that in green because that's what we really want to find. All right, now this is a problem where you cannot directly find the height. You're going to have to find something else first. Eventually, what I want to do is work with this triangle. Right there. That's what I would like to be able to do. How come I can't solve that triangle for the height? Ashlyn? Yeah, I don't have any information. I don't have any sides. I have to figure out a side in this triangle. And the side that I'm going to figure out is right there. I'm going to find the hypotenuse of that triangle. And then, once I find that, I can figure out the height of the mountain. So, let's start with this dotted triangle. Is there anything else I can figure out inside that dotted triangle that's not labeled, but I have the information to figure it out? Yep.
The top angle.
Okay, I could get the top angle. What would you have to find first?
Well, you have a 90 degree, you have a 47 degrees, so then you can just subtract that.
Oh, you're talking about this angle.
Yeah.
Yeah, we're actually not going to need it. We're not going to need that angle. I thought you meant this angle. You are going to need that one. But there's something we would have to find first before we can get that angle that's in the top of the dotted triangle. Yeah?
The other side of the 47.
Yeah, how would you figure out this angle?
Subtract 47 from 180.
Yeah, those two lines, that dotted line intersects something that's horizontal, so that makes a straight angle. It's a 180. Okay, so 180 minus 47 is 133. And now, in order to use the law of sines, you have to know an angle and a side across from it. Well, here's a side. I don't know the angle across from it, but I have the other two, so I can find it. So I'm going to add 35 and 133. I get 168 and subtract it from 180, and I get 12. Okay, and then remember, this side is x. That's what we want to find. So let's use the law of sines to find x. Now here, you just want to remember the idea. It's sine of an angle divided by what's across from it equals sine of an angle, divided by what's across from it. Okay, so I'm going to start with sine of 12 divided by, Victoria, what's across from the 12-degree angle?
Across utilities and batteries.
So for law of sines, we have to have an angle in the top, side in the bottom. 900. Okay, sine of an angle, divide by what's across from it. And anybody think they could set up the other side to solve for x? What angle would I have to use? Great.
Sine of 90.
Remember, we're working with the dotted triangle. Right, we're inside, we're working with this. This is where we are right now. Yep, Alex?
133, because that's the hypotenuse.
Careful, we don't have an, in the dotted triangle, we don't have a hypotenuse.
Well, that's,
And 133 would be across from this side. So I agree, if you want to find y, which I don't care about in this problem, you would use the 133. But what's the angle across from x? Emily? The 35. This is the side you want. That's the angle that's across from it. 35 is across from x. Any question? So Connor, how would I set up what's going to go on the other side here? I think I'm losing people. Ileana?
Sine of 35
Yeah. So basically, all we were doing is looking at that triangle. And my goal temporarily was to find out how long that side was. So if that's 35, that was given. 133, Peter told us how to find that one. To find x, and this was 900, that was given as well. Okay, to find x, you're definitely going to have to use the angle that's across from that side, okay, which is 35. And you have to use the angle that's across from the side you know. Okay? That's like having a row that's complete. You know a side, you know the angle across from it. There's your complete row. 12, 900. This is the row that's missing one thing. Sine 35 over x. So, any questions on why we use the 4 things that I circled? If it's helpful, you could label things A, B, C, alpha, beta, and gamma. It's just a lot of times, if I'm only solving for one thing, I just call it x. If you want to call it A or B, you can do that. It's fine. All right, so let's cross multiply. So we're going to get 900 sine 35 over sine 12. Okay, and that's x. So let's see what we get. And that's probably that is the hardest thing to find in this problem. All right, so 900 sine 35 over sine 12. Okay, so we get 2,482.9. Let's just round it to that. So 2,482.9. Now, since I finally have x, I have the hypotenuse of the triangle in red, which, again, shares the hypotenuse as part of the dotted triangle. And now I can find the height. All right, so So we're going to use that, that, and that. All right, so from the perspective of the 47, Rudy, what's the side that's labeled H? So opposite, adjacent, or hypotenuse. Because remember, this is a right triangle now, so I'm going to go back to what we learned 2 weeks ago. I'm not going to use law of sines on a right triangle. I mean, I could, but that's a lot more complicated. The Sokotoa stuff is a lot easier. Yep, H is opposite. And what about the 2,482.9?
Adjacent.
It's across from a 90, so it's the
The opposite.
hypotenuse. Right, hypotenuse. So what trig function has opposite, which is H, and hypotenuse, which is 2,482.9? Is that? Sine. So the sine of 47 equals, and Orion, what did we say the opposite was?
The opposite would be
So opposite, just the side farthest away from the angle.
the side H.
H, yeah.
I was thinking of that and the other symbol.
And what's the hypotenuse here?
That's that X 2,482.9.
Yep. All right. So to find the height, just multiply by 2,482.9. And same thing here. 2,482.9. I'll just put it in parentheses. All right. So let's see what we got. So I'm just going to take the answer I just had on the screen, which is 2,482.9 times sine of 47. And I get a height of 1,815 meters. Roughly. Actually, it'd be 1,816, I guess, if you round properly. Okay, so that problem's a little tricky, right? Because you got to find another side before you can find the one you really want. Okay, our last problem is a little easier than that one. Okay. If you don't remember the right triangle stuff, I would put that on your reference sheet, like just the word Sokotoa. That might be helpful. All right, so the last problem, you're going to be able to find directly what I asked for. You're not going to have to find something else first. Okay, so we have 2 Coast Guard stations. Okay, and I'm just calling them Zulu and X-ray, Z and X. Okay, a ship sends out an SOS. Okay, so we're going to assume this ship, their GPS isn't working. They don't have a compass. It's nighttime, so they can't see any landmarks. It's cloudy, so they can't see any stars. They got nothing. All right, all they got is their radio. So they send out an SOS. Each Coast Guard station hears the SOS. And Zulu hears the call come in, and they can basically figure out the direction that the call is coming from. Okay, they can get a bearing on the radio signal. So they can basically just say the call is coming from that way. The problem is, if only one station can hear it, they don't know if it's 20 feet that way, 20 miles that way, or 200 miles that way. All they know is it's a straight line in one direction, but they don't know how far away. Okay, the way we're going to describe the direction it's coming in at, and I'll draw this if you're not familiar with it, but it's coming in east of north. 40 degrees to the east of north. Okay, now what makes the whole problem work is the other station also hears the signal, and they can say, well, I heard the signal coming from that way. The other station says, well, I heard it coming from that way. And basically the two signals, or the two bearings, are going to cross. And the call to X-ray indicates the bearing is 30 degrees west of north. Okay, and what they want to know here is how far is each station from the boat. We're going to be able to find both of those things directly. You're only going to have one triangle in this problem. You're not going to have two, like the other one. Okay, and on a test, all that would be all written out for you. Right, so how far is each station from the ship? Okay, so what do you think we want to do with all that information? Yeah?
Draw it.
Yeah, I'm going to draw it. So I'm going to draw a boat. I'm going to draw our Coast Guard stations. And together, that's going to be my triangle. Two stations and the boat. Okay, and I'll scroll back up as I need to look at the information. All right. So first of all, there's the shoreline. Okay, this side will be land. This side, water. Here's my first Coast Guard station. Second one. Now they tell us which one is to the west of the other. So we've got to make sure we label it right. Zulu is west of X-ray. West means to the left. Zulu, X-ray, and they tell me how far to the left. Does anyone remember how many miles they said? 120. Okay, we've got a boat. Another boat. So when they send a call for help, each station is going to hear it. Okay. I don't know if I'm drawing this exactly to scale. The boat is somewhere out there. I don't know if it's closer to Zulu or closer to X-ray. I'm not sure which one. So this might not be to scale. All right. One thing I do need, though, is a line that represents north. North and south is just straight up and down. Okay. Because if I don't have a line that represents north, I can't fill in these angles. Okay. So now let's look at what the angles should be. The call to station Zulu is 40 degrees east of north. East is like right. So 40 degrees to the right of directly north. This is north. So 40 degrees to the right or to the east of north. That's the direction of the first signal. The second signal is 30 degrees to the west. West is like left. Okay, 30 degrees west of north. And actually, I think the boat was closer to the other side. But again, it's not to scale. That's 30 degrees to the left of north. Okay. So if this angle is 40, how much is that angle? Alex?
50.
50. Yep. That would be 50. And if this other angle is 30, how much is the angle on the inside? Molly? How much is that angle?
30.
Well, together they've got to make a 90. So that's 30. 60, yeah. And now we've got a 50 and a 60. So Peter, how much does that add up to?
110.
110. And so how much does that leave for this angle? 70. The reason I want the angle at the top is because I know the side across from it. You here's your complete row in the law of sines. Sine of an angle, divide by what's across from it. Now, let's just call that side A and that side B. That's the distance from the boat to each station. So now, let's find A. Right, so take sine of an angle, divide by what's across from it. Sine of 70 over 120. And if you want to find A, you're going to use the angle that's across from it. If you were making a table, that's the one that would be in the other column. Sine of 60 over A. So on your calculator, you type in 120 sine 60 over sine 70. Okay? So that you can find directly. You don't have to find something else first, like in the last problem. And that's the distance from the boat to the first station. And then do it one more time to find the distance from the boat to the other station. Still going to use sine 70 over 120. Okay. But this time you're going to use the angle across from B, which is how much? 50. Okay. Sine of 50 over B. And you cross multiply just like we did before. 120 sine 50 over sine 70. And you'd have to just type that in and see what you get. Now, if they were going to do a rescue, do you think you would always just send equipment from the station that's closer? What might influence that, besides just how far away it is? Yeah?
What if they don't have all the necessary tools?
Yeah, maybe one station has a Coast Guard cutter, which is a boat, and the other one has a helicopter. Well, even if they're further away, the helicopter can probably get there faster. Also, you've got to assume that the boat is drifting, right? If they don't have any engines, say it's going to take 4 hours to get to the boat with a helicopter. They can't go to where the boat is now. They have to fly to where the boat will be in 4 hours. So maybe the boat, by the time they get there, will be 200 miles that way. So they need to fly to that spot. Right? So there's a lot of factors besides just the distance they got to take into account. Okay, but that just kind of simplifying it. Just find the two distances. That's all we did. All right. So that pretty much finishes up the law of sines. Okay, so tomorrow we'll do law of cosines, and on Thursday we'll do a review. So the homework tonight on 267 is 29 to 35, just the odds, 39 and 43.